LaHouse Resource Center is a showcase of solutions for producing high-performance homes for our hot, humid climate and natural hazards, all based on results of building science research. It demonstrates a range of proven ways to gain so many benefits to enjoy every day and to have more control over our lives. Think about it. As we shape our homes, we shape our future.
One of the 4 high-performance building systems demonstrated in the construction of LaHouse is known as advanced framing, an optimum value engineered method of wood frame construction used in the 2-story west wing of LaHouse and revealed in cutaways in the front porch closet and the laundry room. It uses 2x6 studs spaced 24 inches apart and has been shown to cost about the same as standard framing, but with more insulation and less waste, while just as strong as traditional framing with 2x4 studs spaced 16 inches apart. Advanced framing achieves high strength, energy efficiency, and low cost by using strategic techniques that avoid unnecessary use of non-structural lumber, align openings with studs to save lumber, and takes advantage of the strength gains of stacked framing, where wall studs, ceiling joists, and roof rafters are all aligned. So, despite using wider, more expensive studs, fewer are needed, saving labor and cutting waste. The advanced framing in LaHouse was enhanced to meet the design criteria of a high-wind hurricane zone and to provide protection from the Formosan subterranean termite, the most destructive insect on the planet that can do major structural damage in 1 year. In addition to soil treatment and steel mesh termite shields, treated lumber and sheathing were used as a 3rd layer of defense against termites and decay. The stud color indicates it is borate pressure treated. In part 2 of this video, you'll see how the advanced framing in LaHouse was assembled from start to finish and why. LaHouse Advanced Framing Part 2, from the ground up. A sill gasket was placed along the edge of the slab for 2 purposes. Number 1, it seals the gap under the bottom plate to stop a major source of air leakage, and number 2, it stops moisture that wicks up through the concrete from wetting the wood. This is known as a capillary break. The bottom plate was placed over the gasket and anchor bolts that had been set in wet cement every 16 inches and are secured with 3-inch washers for high wind resistance. The master bedroom and bath have raised wood floors to demonstrate alternative raised foundation systems. Both use borate pressure-treated floor joists and plywood decking for solid, no-squeak, durable floors. Floor systems are connected to piers or concrete block stem wall foundations with high load capacity hurricane foundation straps. Southern pine 2x6 lumber studs are spaced at 24 inches because wider lumber can be spaced further apart. Why do this? To have room for thicker insulation, and fewer studs mean fewer insulation gaps, creating a more energy-efficient wall. Typical wall framing uses extra studs in corners and in interior wall intersections to have a nailing surface for hanging drywall, but that creates voids with no insulation. Advanced framing uses energy corner details that allow insulation in corners and T-joint intersections. Header framing over windows and doors are sized for the load or omitted when not needed in non-load-bearing walls. This saves lumber. Notice that the double header boards are placed to the exterior, leaving room for 2.5 inches of rigid insulation where there would normally be none. It also reduces nail popping tendencies. Open web wood trusses were used between floors instead of lumber joists to allow air ductwork to run between the floors. The treated laminated strand lumber band joist between the floors provides strong stability. The band is insulated with spray foam to prevent air leaks and energy-wasting duct losses in the space between the floors. The second-story walls studs are in line over the first-level studs. Although stacked framing normally allows single top plates because of the direct alignment, LaHouse needed double top plates for its high wind load criteria. The roof is framed with rafters spaced at 24 inches, same as the wall framing. A raised top plate framing method allows insulation to fit over the exterior walls. A hip roof design is aerodynamic, so naturally is more wind resistant than other roof styles. LaHouse uses metal hurricane hardware to connect all components of the framing to create what's called a continuous load path from the foundation to the roof. LaHouse was fortified for high wind loads suitable for coastal locations. The walls have plate-to-stud connectors on every stud to resist uplift forces, corner hold-downs to resist the forces that can push or tip a building off its foundation, metal straps that tie the second level to the first level, and window headers to framing, pre-sloped U-shaped hurricane ties connecting rafters to the top plates for extra reinforcement against uplift forces on the wide roof overhang, and rafter straps at the roof peak to hold the two sides of the roof framing together. Load-bearing interior walls are also connected for high wind forces. The master bedroom wall used tall sheeting panels that cover both the bottom and the top plates. The panels are attached with a specified double nailing pattern to resist uplift as an alternative to using metal stud-to-plate connectors. This is a vented attic with ridge and soffit vents, so foil-faced roof decking was used to provide an energy-efficient radiant barrier for a cooler attic. The thicker decking is attached with ring shank nails to resist pullout from uplift. The wind-fortified walls are fully sheathed with thicker panels to resist racking or leaning forces, and are arranged so as to span and connect the first level to the second level framing. Blocking is added behind the seams so all panel edges are nailed to framing. Two termite and decay-resistant types of sheathing are exhibited at LaHouse. On the front side is borate-treated plywood, while copper-treated OSB sheathes the backside. Cellulose insulation made from recycled newspaper with a stabilizing adhesive and borate fire retardant was sprayed to fill the wall cavities, providing R19 insulating value between the studs. Sprayed insulation that fill every nook and cranny without voids or compression provide about 30% better performance than typical methods. In the attics, R38 loose-fill fiberglass was blown into the second-story attic, a low-cost option with full coverage. Specialized attic ventilation baffles allow insulation over the top plate while maintaining attic ventilation and preventing energy-wasting wind washing. This wing of LaHouse has 6 types of windows and a door that meet Energy Star label criteria for the Deep South. They have insulating clear low-E glass with a low solar heat gain coefficient to greatly reduce summer heat gain. Those in the bedrooms and master bath are also high wind pressure and impact rated, so they don't need exterior hurricane shutters. The nursery windows have metal-clad wood frames to match those on the front porch. The master bedroom has strong, energy-saving vinyl frame windows and a metal door. The sidewall has economical vinyl frame windows protected with hurricane shutters. The Bahamas-style shutters also provide attractive energy-saving shade and privacy. The back upstairs office windows have high-performance fiberglass frames with an elegant wood interior. A few points to consider. Advanced framing complies with building codes even in high wind zones, but some modifications may be needed. It uses the same skill set as conventional framing, but there is a modest learning curve before you can expect time and cost savings in the construction. Finally, if there is a concern about drywall in wet, humid weather conditions becoming wavy in 24-inch on-center spaced framing, there are several solutions. LaHouse used half-inch paperless drywall with a moisture-resistant core. Other solutions are ensuring straight framing, humidity control systems, or thicker drywall. Some lessons learned in building LaHouse. It is helpful to create and use framing drawings to ensure lumber-saving details and proper assembly of details, such as the energy corners. Workers need advanced training in both the advanced framing details and their purposes, as well as the quality controls required. Deeper wall cavities call for specialized spray insulation installation methods. So make sure your installers are trained and experienced in insulating 6-inch wall cavities. In summary, advanced framing provides higher energy efficiency at similar cost to standard framing, once past the learning curve. Fortified advanced framing for high wind and termite resistance does add cost, but offers lifetime protection for the owner's investment and peace of mind. You're invited to explore LaHouse inside and out. Its cutaways, feature signage, models, publications, library, and the website, and to learn about how you can shape your future with a high-performance home.